3C, in the free response section, says for the interval -5 to +6, on what open intervals, if any, is a graph both increasing and concave up, and give reason. Okay, so first of all, an open interval just means that we don't include the endpoints. And we should understand the general principle that the G graph here is a slope function. And if the slope function is sloping up, it means the derivative of the derivative function is positive. And that means we have positive concavity. The same can be said when the slope function or the derivative function is pointing down. We know that the derivative of the derivative function is negative. That means we have negative concavity. Okay, so that's a general concept that we should know. And for the part D, we want to understand this idea the point 2 is that inflections occur where the second derivative changes from positive to negative or negative to positive, or in other words, where the first derivative changes from sloping up to down or down to up. So where we have min and maxes on F prime is where we're going to find inflection points. So looking at 3C, for what values of x between -5 and +6 is F both increasing and concave up? Well, increasing means that the derivative is positive, so the function, the G function, is positive throughout that whole interval. So that means that for that whole interval between, I'm going to show it on the number line here, between 0 and 6, and at 4, it's equal to 0 as well. So between here and here and here and here, we know that the value is positive. So that means that the slope is positive. So it's pointing up. We actually have 0 slope here, pointing up like that. The second derivative gives us the concavity. And so the concavity is happening where it's sloping up. Okay, so we're going to slope up in this region. So from 0 to 1, we have positive concavity. From 1 to 3, it's 0 concavity. Okay, we have no slope. From 3 to 4, it's pointing down. So we have negative slope. And then from 4 to 6, it is sloping up. So we have positive slope on the slope, or the positive second derivative, which means we have concave up. So where we have the concave up and increasing is going to be in the region. This will be my solution then. So between 0 and 1, it is both concave up and sloping up. Between 4 and 6, we have both concave up and sloping up. And we can write the interval like this, and we don't include the endpoints to keep it an open interval. For part D then, it says find the x-coordinate for each inflection point on the graph. So give your answer. So inflection occurs where the slope or the second derivative changes from positive to negative or negative to positive. So again, I can do a slope chart here, or concavity chart. So I know that the second derivative of f of x, we're going to change from negative second derivative there. So I'm going to start at 0. We have positive, and to 1. From 1 to 3, we have 0. From 3 to 4, we have negative concavity. And from 4 to 6, we have positive concavity. So at x equals 4, we have an inflection. Okay, and the reason is the concavity changes, or G prime, which is F double prime, changes from negative to positive. Okay, if we look at the mark scheme, for D, it says we need the answer at x equals 4, and the reason is the derivative of the slope of the G graph changes from increasing to decreasing at x equals 4. Okay, in essence, that we have a minimum point at x equals 4. Okay, we could also state this as well. There is a minimum at x equals 4 would be justification as well. For part C, we get 1 mark for the intervals, which we have been given here. And for reasoning, we can show our slope charts. That would be a good way to show the reasoning of how we ended up with these intervals.